Good afternoon, children.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
Good afternoon. Yeah, so I can see Nandini, Priyasha, Ram, Kanishka, Lakshmi, Subbalakshmi, Shreya, Shri, and Ananya. Hi, Ananya. Finished your exams at school?
No, ma'am, it is still 9th January.
Okay, fine. So you were not able to take up the classes this week, right? All the classes this week, right?
Yes, ma'am, all the classes, yes.
Yes, Ananya, but can you promise me that you will find time to watch all the recordings, because every class is important, and in that sense, all these revision classes, we have discussed many important stuffs which you may know, but you have to check the recording so that I'm happy that you have not missed anything.
Sure, ma'am, I will do it once these exams are over.
Yeah. So watch one by one and keep posting me. Keep me informed that you finished watching the recordings. You don't
Okay.
As you finish, you keep letting me know that you've finished one by
Yes,
one.
ma'am.
All right. Yeah. Okay, fine. If possible, if you write out them in your class work, if at all, you can write even only the answer. If you don't have time to write the question, write only the answer, or whatever you've practiced. If you can just share the pictures of them also on WhatsApp, I'll be happy. They don't have to be neat, but just like scribbling and practicing so that you make sure you know them. That those pictures,
Yes.
if you can share on WhatsApp with me, I'll be happy.
Okay, ma'am, sure.
Yeah. Fine. All right, children. So we are doing real numbers. We'll continue with that. What prime factor or factors must the factorization of a number have so that the number raised to the power of any natural number can end with the digit 0? What prime factor or factors must the factorization of a number have? So you're given a number and it's a composite number. You're able to write it as a product of primes. You're able to write it as a product of primes. Now, what prime factors must be there in the factorization of that given composite number so that when the number is raised to any natural number, its value will end with 0. So the answer is the prime factorization of the number must have the factors 2 and 5, because 2 into 5 is 10. 2 into 5, sorry. Yeah, 2 into 5 is 10. See, now 2 to the power 5, 2 raised to any power will not end with the digit 0. 2 raised to the power 5, say, is 32. In fact, 2 raised to any power will be a value whose units digit will not be 0. 2 raised to any power, 2 to the power 6, 7, 8, 9, 10, 11, 12, whatever. 2 raised to any power, the value of that will not end with 0. Because the prime, there is only one prime, 2. Now, similarly, 5 raised to any power. 5 raised to the power 5, 6, 7, 8, 9, 10, whatever. 5 raised to any power cannot end with the digit 0. The value of that number cannot end with the digit 0. Now, for example, 5 raised to the power 5. What is 5 raised to the power 5? 625 into 5. So it's 3125, I guess. Okay. So see, it will always end with the digit 5. It will always end with the digit 5. So if the value has to end with the digit 0, then what prime factors must be there in the factorization of the given number is the question. So the prime factors must definitely include 2 and 5, not 2 or 5, 2 and 5. 2 and 5. Because 2 and 5, the product of 2 and 5 is 10. The product of 2 and 5 is 10. Now, for example, 2 to the power 4 and 5 raised to the power 2. That's okay. They can have different powers. That's fine. But there should be at least 1 2 and 1 5. The number of 2s and 5s need not be equal. The number of end with 0. The question is end with 0. So if there's 1 0, that is enough. It can maybe the units and tens digit is also 0, or units, tens and hundreds digits they're all zeros. That's fine. But the condition is the last digit, that is the units digit, must be 0. End with the digit 0. That means the units digit should be 0. So there should be 1, 2 and 1, 5, because the product of 2 and 5 is 10, which has a 0 in the units place. So there should be at least 1, 2 and 1, 5. Now, supposing there are, more that there are more than 1, 2 and 1, 5, they can have any powers. Now it can be like 2 to the power 10 and 5 to the power 2. That's fine. But see, the thing is, there is 1, 2 and there is 1, 5. That's enough. There is 1, 2. There is 1, 5. That's enough. So the value of that expression. So along with the other primes, Now, for example, there is a composite number x whose prime factorization is 2 to the power 7 into 3 into 5 to the power, say, 3 into 11. Now the value, when you find this composite number, will definitely end with the digit 0, because there is 1, 2 and there is 1, 5. There can be the other primes. Along with the other primes, there is also 1, 2 and 1, 5. And 2 5s are 10. So this composite number definitely ends with the digit 0. There may be zeros in the other places, but it will definitely have 1, 0. That means the units digit will be 0, because there is 1, 2 and 1, 5 in the factorization of x, of the composite number x. Okay. I'll share the answers, children. Maybe tomorrow I'll share. I'm just making the presentations. So in a hurry, I just made only the questions. I didn't have time to write the answers. So I'll prepare the presentation and I'll share the answers with you by tomorrow, or just give me some time. I'll share it with you. So we are not writing anything in today's class. We'll just discuss a bunch of questions, and the answers of the question and answers will be shared to you on WhatsApp. Once you receive them, you can complete it in your classwork notebook. All right, children? Please say yes.
Yes, ma'am.
All right. And what about, we didn't have a class yesterday. What about day before yesterday's class? How many of you completed the notes of Thursday's session? Thursday's session, children? Kanishka?
Yes, ma'am.
Finished? Did you complete your classwork?
Thursday session, ma'am.
Yeah, Thursday. When I think we did real numbers on Thursday.
Yes, ma'am. Completed, ma'am.
Nandini, Pranav, Priyasha, Ram, how many of you completed your classwork?
Completed, ma'am.
Very good.
Complete.
Very good. Nandini, Shreya, Shri, and Priyasha, along with Kanishka. Others, please, Sneha and Harini were not able to attend the class. Please watch the recordings and write out the contents in your notebook. I think we did this in the last class, right?
Yes, ma'am.
No. Okay. Will the decimal expansion of this expression terminate? Will the decimal expansion of this expression terminate? So 9261 divided by 2 cubed into 3 into 5 to the power 4 into 7. So let us simplify. 9 plus 2, 11, 11 plus 1, 12, 12 plus 6, 18. So it's divisible by 3. 3 ones are, 3 threes are 9, 0, 3 eights are 24, 2, 3 sevens are 21. And now this number, there is 7 here. 7 ones are, 7 fours are 28, 2 remains, 7 fours are 28, 1. So the simplified version of the given expression, the simplified form of the given expression is 441 divided by 2 cubed into 5 to the power 4. So you can decide if the expression given will have a terminating or a non-terminating decimal expansion only after writing the expression in the simplest form. You must first write the given expression in the simplest form. looking at the, see, when you just look at the expression, you find the other primes 3 and 7. So because the denominator has primes 3 and 7, we should not hastily conclude that the given expression will have a non-terminating repeating decimal expansion, because we have understood that the prime factorization of the denominator must have primes 2 or 5 or both 2 and 5 for the expression to have a terminating decimal expansion. For the given number or for the given expression, excuse me, children. Yes, children. So we have understood that, or we know that the prime factorization of the denominator of the given expression must have the primes 2 or 5 or both 2 and 5 for it to have a terminating decimal expansion. If the denominator has primes other than 2 or 5, then that will have a non-terminating repeating decimal expansion. Since we're dealing with fractions, only these two types of expansions are possible. Now, the case of non-terminating, non-repeating decimal cannot happen here because we are dealing with P by Qs. And we know that P by Qs can have only a terminating decimal expansion or a non-terminating repeating decimal expansion. So we are not talking about non-terminating, non-repeating decimal expansions because they do not have a P by Q form at all. So that decimal expansion is not possible here because we are working with numerator by denominator, which can have only these two decimal expansions, terminating, non-terminating, repeated. So for terminating, 2, 5 must be the primes in the denominator, nothing other than that. If it has one factor also, one prime other than 2 or 5, then that fraction or that expression will have a non-terminating repeating decimal expansion. But before we conclude, we have to write the given expression in the simplest form. We need to write the given expression in the simplest form. So now the other primes which we see in the expression, the other primes we see in the expression are 3 and 7. So you must check if the numerator 9261 is divisible by 3 and divisible by 7. If it is divisible, simplify. If it is not, see, you don't have to check if 9261 is divisible by 11 because the denominator is not divisible by 11 because the denominator does not have 11 as a prime. Clearly the denominator is divisible only by 2, 3, 5 and 7. Clearly the denominator is divisible only by 2, 3, 5 and 7. Now 2 and 3 are fine. I'm sorry, 2 and 5 are fine. We're trying to eliminate 3 and 7 if possible. We're trying to eliminate 3 and 7 if possible. Yeah, so we are trying to, if possible, we should get rid of 3 and 7. So we just have to check if the numerator is divisible by 3 and divisible by 7. And it was possible in this case. So the simplified form of the given expression is what you see here. And clearly the denominator is made up of only 2s and 5s. So the given expression has a terminating decimal expansion. And the question is, will the decimal expansion of the whatever is given terminate? Yes, it will terminate. The answer is yes, it will terminate. And now who can tell me after how many places will it terminate? The answer to the question is yes, the decimal expansion will terminate. Now the next question is, after how many places will the decimal expansion terminate? Sorry? Again? 4, yeah, 4. Correct, Kanishka, 4. It will terminate after 4 decimal places. And who can tell me the decimal expansion? Find the decimal expansion. Of course, without performing the long division. Find the decimal expansion without performing the long division. Tell me.
Zero point 0.0882.
Yeah, 0.00.
0.882. 0.0882.
Okay, 0.088. 1 minute. Eight, I'm so sorry. 88.
2, ma'am.
2. Okay. Is this correct, children?
Yes, ma'am.
Yes, children. Yeah. So 441 divided by into 2. So 2 to the power 4 into 5 to the power 4. So this is 882 by 1 followed by 4 zeros. Yeah, 0.0882. Very good. All right, children. Very good. Yeah, complete this. This we do not have actually HCF of the relationship between HCM. Okay, 1 minute before that, let's just recall this. So we know that when we talk about two numbers, LCM of A and B into HCF of A and B is equal to A into B. HCF of A and B is equal to the product of the two numbers A and B. We know this. We only have this just to be safe in case you're asked to complete this, equation which connects or which brings a relationship between the HCF and the LCM of three numbers. So now see here, what do you have? LCM of X comma Y, then complete LCM of Y comma Z, LCM of X comma Z. Then the numerator, it's a product of the three numbers, X into Y into Z, into LCM of the three numbers, LCM of the three numbers. HCF of three numbers X, Y, Z is equal to the product of the three numbers into the LCM of the three numbers, the product of the three numbers into the LCM of the three numbers. divided by LCM of x and y into LCM of y and z into LCM of x and z. You will not get questions based on these, based on this relation. Just remember, simply remember this. In case you're asked also, you can use this relation and find the answer. This is the relation connecting the HCF and LCM of three numbers x, y, and z. Yeah, children. I'll just get back, children. Read this question and I'll just come back.
Ma'am?
Yes?
Ma'am, I came, ma'am.
Okay, Meera. Fine, fine. Yeah. Just a minute, children. Yeah, thank you, children. So a merchant has 1,000 liters of oil A, 2,800 liters of oil B, 1,680 liters of oil C. He wants to sell the oil by filling the three kinds of oil in tins of equal capacity. He wants to sell the oil by filling the three kinds of oil in tins of equal capacity. What should be the greatest capacity of such a tin? How many such tins should he buy in all? So the first class, on real numbers, we understood, it's very easy to find out if you have to find the LCM or the HCF for the given situation. So clearly here it is the, please complete my statement. Clearly here we have to find the dash of the three numbers. LCM or HCF of the three numbers?
HCF.
HCF.
Yeah, we have to find the HCF of the three numbers. So you all know how to find the HCF. Okay, so you all know how to find the HCF. So the HCF of the three numbers. Okay, so the HCF of the three numbers is 80. The HCF, you know how to find the HCF. The HCF of the three numbers is 80. Now the greatest capacity, or the not greatest again. So the capacity of a tin, capacity of a tin should be 80 liters. Should be 80 liters. The greatest, see, why greatest capacity they are asking? Because you can buy even 1 liter tins, no? You can buy 1 liter tins and you can fill this oil, fill the oil of all the three categories in 1 liter tins. Okay, so then oil A, you will be making 1,200 tins. Oil B, you will make 2,800 tins, and oil C, you will make 1,680 tins. You can even buy, cans of capacity 2 liters. You can even buy cans of capacity 2 liters. In that case, oil A, you will have 600 cans, oil B, 1,400 cans, and oil C, 840 cans. You can also buy tins of 10 liters. You can buy tins of 10 liters of capacity 10 liters. You can also buy tins of capacity 10 liters. In that case, you will have 120 tins or cans, whatever it is, of oil A. If you buy 10-liter cans, then you will have 120 cans of oil A, 280 cans of oil B, and 168 cans of oil C. You can also buy 20-liter cans. You can also buy 20-liter cans. You can buy half-liter cans. You can buy 100 ml cans. You can buy 1 ml cans. So like this, the answer is many. That is why the word greatest, that word has a lot of, adds, a lot of, this word greatest is very important in the question here. What should be the greatest capacity of such a tin? Because you have many choices. You have many choices. You can buy many cans of capacity 1 liter, 2 liters, 5 liters, 10 liters, 20 liters, 40 liters. So you have many options. What is the greatest capacity of such a tin? So the greatest capacity is the HCF. HCF is equal to 80. So the greatest capacity of such a tin can only be 80 liters. Now, supposing you buy 100, supposing you buy, cans of capacity 100 liters, that you can fill oil A in 12 cans, oil B in 28 cans, but oil C, no, you cannot. That is, some oil will be left. You will be able to fill it, but not completely. So after you will make like 16 cans and then 1680 liters. Correct, is is 1600 liters plus 80 liters. 1680 liters is 1600 liters plus 80 liters. So this one 100 liter cans, you will make 16 cans. 100 liter cans, you will make 16 cans. What about this? In the 100 liter can, if you pour this, it's only 80 liters. So you cannot, the can will not be full of oil, right? So this will be left out. 80 liters will be left out. So this is the greatest capacity the can have. That's what is the question. What should be the greatest capacity of such a tin? The greatest capacity of a tin should be 80 liters. Okay, and then how many such tins should he buy in all? In all. So what's the capacity? What's the total quantity of oil he has? 1200 liters plus 2800 plus 1680. This one adds to 0, 8, 6. Okay. So all this adds to so many liters. So 5680 divided by 80. Divide 5680 by 80. 8 sevens are 56. 8 sevens are 56. 8 is the remainder. 1 0. So 71 cans. 71 cans. So he has to buy 71 cans. The merchant has to buy 71 cans of capacity 80 liters. Then he will be able to empty all the oil, meaning oil A, oil B, oil C in 71 cans. Exactly. No oil will be left out. No can also will be left out. No oil of any type will be remaining. No can also will be remaining. Oil will be emptied into the 71 cans and the cans will be completely filled with oil. If you have to find the cans of each type, this is the total number of cans he has to buy. Supposing you have to find, the number of cans for each type of oil, then you have to divide separately. For oil A, how many cans he'll need? Number of cans he needs for number of cans required to empty the oil, the oil of type A will be 1200 by 80. Oil B, he'll need so many cans. So many cans. Oil C, he'll need so many cans. So 15 8s are 120. Then here 8 3s are 24. 8 3s are 24. 8 5s are 35. 21. Add 5 plus 5 10. 1 1 carry over. 5 6 7. So you can find it anyways. You can find the number of cans needed for oil A, oil B, oil C, and then add to find the total number of tins he has to buy. Or you can add the capacity 2800 plus 1200 plus 1680. You can add the capacity and then divide by 80. So then you will get 71 straight away. Anyways, you can do it. All right, so we have answered both the questions. We have 2 questions to answer here. Greatest capacity is the HCF, which is 80 liters. And how many tins should he buy? 71 tins. This answer 71 can be worked in 2 ways. Like what you see on the screen now, separately you can find for oil A, oil B, and oil C, and then add. Or you can add the capacities 1200 plus 2800 plus 1680 and divide by 80. So you will get 71 straight away. Okay, so here also it is, children, the HCF, because find the minimum number of rooms required if in each room the same number of students are to be seated and all of them being in the same standard. All right, so I'll share. So it's just HCF and the working is going to be simple. I'll share the answer. You can, as you work, you will definitely understand. We'll go to the next one. Yeah. So we need to find the largest 4-digit number that is exactly divisible by 90 and 144. We need to find the largest 4-digit number that is exactly divisible by 90 and 144. Now, supposing we'll take a simpler question. Supposing we have to find the largest, two-digit number exactly divisible by say 4 and 7. 4 and 7. Okay, find the largest two-digit number exactly divisible by 4 and 7. So we need to first find the LCM of 4 and 7. What's the LCM of 4 and 7? 28. So 28 is the smallest number. Listen carefully. 28 is the smallest number that is exactly divisible by 4 and 7. 28 is the smallest number that is exactly divisible by 4 and 7. You should not find the HCF here, because that number should be divisible by 4 and 7. The number which you're going to find should be divisible by 4 and 7. So you have to find a number greater than the given numbers. The number which you find should be divisible by 4. Divisible by meaning divisible like this, divisible by 7. So this should be the LCM. So now you see that the LCM, least common multiple, the LCM is the smallest number that is exactly divisible by 4 and 7. No, but the question is find the largest two-digit number. So it should be a multiple of 28. You should find the largest two-digit number exactly divisible by 4 and 7. 28 is exactly divisible by 4 and 7, but it's not the largest two-digit number. So find the multiples of 28. 28 2 times is 56. 56 is also a two-digit number that is exactly divisible by 4 and 7. 56 is also a two-digit number that is exactly divisible by 4 and 7. But this is not the required answer. 28 3 times. 2 carried over. 84. 84. 84 is also a two-digit number exactly divisible by 4 and 7. Is that the required answer? We'll have to confirm by working 28 into 4. 8 4s are 32. 3 carried over. 4 8s are 4 2s are 8 plus 3 11. Yeah. Now this is a three-digit number. This one is a three-digit number. So 84 is the largest two-digit number that is exactly divisible by 4 and 7. So the steps are something like this. You have to find the LCM of the given two numbers and then find that multiple of the LCM which satisfies the condition given in the question. We need to first find the LCM of the given two numbers. Then find that multiple of the LCM which satisfies the condition. So we first found the LCM of 4 and 7, which is 28. Then 28 2s are 28 3s are 28 4s are. Now supposing you have to find the largest four-digit number, sorry, three-digit number. Okay, supposing you'll have to find the largest three-digit number. So the LCM of what did I say? 4 and 7 is 28. So the largest two-digit number, exactly divisible by 4 and 7 is 28 into 3, which is 84. Now largest three-digit number exactly divisible by 4 and 7 is equal to, we'll have to work that. There's no shortcut or something, so you have to do. So we know that 28 into 10 is 280. So we'll jump. We'll not do 28 4s or 5s or 6s or 7s, then go slowly like that. We'll just try to find bigger multiples. So 28 into 10. 28 into, let's say 30. What is 28 into 30? 840. So we are getting close. Okay, we'll have to find the largest 3-digit number. We're getting close. 28 into 30 is 840. So then just try 28 into 35. Now find, tell me children. Please do this for me. You should not go beyond 999. Got it, children? Oh, shouldn't take this long. Are you all working or sleeping?
$980.
Yeah, I'm just coming. Priyasha, is it?
Yeah, ma'am. 980.
980, correct?
Yeah.
Yeah,
Yes,
yeah, I'm
ma'am.
just coming. Yeah, I'm just coming. Yeah. Yeah, children, what about the others? Is 980 correct? All of you get that? Yeah, good. 980 is the required number. Very good. So 980 is the largest 3-digit number. See, 980 is not the largest 3-digit number. It's the largest 3-digit number exactly divisible by 4 and 7. All right. So here we have to find the LCM and find that multiple of the LCM. That is, the LCM is 24, 28. So 28 2s are 3s are 4 times, 5 times, 6 times. So multiples. Okay. You'll have to find that multiple of the LCM which satisfies the condition given in the question. That is the largest 4-digit number. So that's what you'll have to do here, children. Do the same thing. Find the LCM of 90 and 144 and find that multiple which satisfies the condition. All right. See this one. A rectangular courtyard is 18 meters 72 centimeters long. Okay. And 13 meters 20 centimeter broad. It is paved with square tiles of the same size. It is paved with square tiles, not rectangular tiles, square tiles of the same size. Find the least possible number of such tiles. Least possible number. That means least possible number of such tiles, meaning the tiles must be of the greatest size. Then only you can buy least number. See, if you buy very small tiles, that means you will buy more tiles. You'll have to buy more tiles. But the condition is you should find the least possible number of such tiles. You want to buy as less as possible. You don't want to find, the condition is you should find the least possible number of such tiles. So you want to buy as less as possible. That means the size of the tile should be as great as possible or as big as possible. If the size of the tiles are small, then you should buy many tiles. If one tile is big, if the tiles are big in size, so then you will buy less number of tiles. And that is what the condition here. You should buy as less as possible, least possible number of such tiles. So you want to buy less number of tiles. That means you must choose the tile of the greatest size. You want to buy less tiles. So big size you must buy. The tiles you buy should be of big size. And what is that big size? That is what we'll have to find. So for that, we need to find the HCF of the two numbers, because LCM, I told you that first class, if I repeat it again, it will take 10-15 minutes. So that first class, we understood why LCM or HCF. So clearly here it is the HCF. So we need to find the HCF of 18 meters, 72 centimeters and 13 meters, 20 centimeters. All right, so 18 meters, 72 centimeters is nothing but 18 meters is 1800 centimeter plus 72 centimeter. So which is 1872 centimeter. Similarly, 13 meters and 20 centimeters is 1300 centimeter plus 20 centimeter, which is 1320 centimeter. Now we need to find the HCF of the two numbers. The HCF of 1872. Find out and tell me, children, what is the HCF of these two numbers? Please work and tell me the HCF of these two numbers.
Twenty-four, ma'am.
24. Again, that's from Priyasha. Very good. 24. All right. So the HCF of the two numbers is 24. Now, what does this number tell us about the situation given here? So that means the side of each square tile should be 24 centimeter. Yeah, because we have converted the numbers to centimeter, right? So this indicates the HCF indicates that the side of each square tile should be 24 centimeter. See, as I told you in the beginning, you can buy square tiles of size 1 centimeter, 1 centimeter by 1 centimeter. You can buy 2 centimeter by 2 centimeter, 2 centimeter by 2 centimeter. But you'll have to buy more tiles. If the size is small, then you'll have to buy many tiles. But the question or the condition is find the least number of tiles to be purchased. So that means each tile should be of the maximum possible size. And that size is 24 centimeters. The side of each square tile, not the area, the side, because 24 centimeter is a length, not area. The LCM of 1872 centimeter and 1320 centimeter is 24 centimeter, and 24 centimeter is not the area of the tile, it is the length of the side of the square tile. So now the number of tiles, the next question is the number of tiles. We found the side of each square tile by finding the HCF of the two numbers. Now we'll have to find the number of tiles. The number of tiles is equal to, can anyone guess? Guess how to work, not guess the final answer. Can anyone tell me how to proceed?
1872 by 24 and 1320. 24 I had to add.
Yeah, 1872 by 24 I heard, then 1320.
By 24.
Very good, fine. Yeah, I'll just put your answer in a different way. So number of tiles is equal to area of the floor of the courtyard. Okay, area of the floor of the courtyard divided by the area of each square tile. Area of each square tile. Each square tile. See now, supposing the floor area is say what do I say? 100 meters square. All right. Supposing the floor area is 100 meters square, and you buy square tiles of side 2. You buy square tiles of side 2 meters. Okay, let me make it centimeter square, no? Just to understand. Yeah. So supposing the floor area is 100 centimeters square, then and you buy square tiles of side 2 centimeters. So how many tiles you have to place? How many tiles you have to place to cover the area of 100 centimeters square? When you place one tile, it will occupy an area of 4 meters square. When you place one tile, it will occupy an area of 4 meters square. 2 into 2, 4. When you place the second tile, another 4 meters square. Sorry, centimeter square. Okay, and another tile that will occupy an area of 4 centimeters square. So every time you place a tile, it will take up an area of, or it will cover an area of 4 meters square. So clearly 100 by 4. You need to place 25 such tiles to cover the total area of 100 centimeters square. So clearly the formula is area of the floor by area of each tile. Area of the floor divided by area of each tile. Because the total area to be covered by the tiles is 100 centimeters square. And when you place one tile, it will cover an area of 4 centimeters square. 2 into 2, 4 centimeters square. One tile covers an area of 4 centimeters square, but you need to cover a total area of 100 centimeters square using all the tiles, which means you need 25 such tiles. 25 into 4 is 100. So that's the formula. Area of the floor by area of each square tile. Area of the floor, rectangle. So length into breadth, 1872 into 1320 divided by area of each square tile, 24 into 24. That'll give you the number of tiles you'll have to purchase. As I told you, children, I'll be sharing the answers. So you don't have to write on anything now. Over to the next one. Is that understood, children?
Yes, ma'am.
All right. So the HCF of the two numbers, convert both the numbers to centimeter. Then find the HCF of the two numbers. That is the HCF of the length and breadth. Whatever answer you get will represent the length of the side of the square tile. Then to find the number of tiles, it is the area of the floor divided by area of each square tile. If X is equal to Y is equal to and Z is equal to find the LCM of X, Y, Z. Yes, children. Tell me what's the LCM of, I don't want that product. I don't want that final product. But what are the factors you need to consider to find the LCM? You must write all the primes or only the common primes?
All the primes.
You must write all the primes. You must write all the primes that you see here.
And
All the
highest
primes.
power.
With the highest power. Very good. Who was that? Lakshmi?
Yes, ma'am.
Yeah. All right, good. So we'll have to write all the primes you see. So we can see the prime number 2, you can see 3, you can see 5, you can see 7, you can see 11, and you can see 13. These are the different primes you see in the factorization of x, y, and z. 2, 3, 5, 7, 11, and 13. Now raise these primes to the highest power you see here. It's not, we are not writing. Yeah, we are not writing the common primes. You must write all the primes you see. Raise the primes to the highest power. Yes. So 2 to the power?
4, ma'am.
3 to the power?
1.
1. Or simply 3. 5 to the power?
3, ma'am.
7?
1.
Yeah. 11?
1.
13?
1, ma'am.
Yeah. So you don't have to write 1, but we're just trying to understand that. You don't have to write 1. This product, I'm not expecting you to find the product now. You can do it when you work it in your classwork. So this product will tell you the LCM of the 3 numbers x, y, and z. Now next is the HCF of x, y, and z. So for LCM, you must write all the factors and raise the prime factors to the highest power. All factors, highest power. LCM, all the prime factors you see and raise the prime factors to the highest power there. Like for 2, you have 2 square, 2 cubed, and 2 to the power 4. So the powers are 2, 3, and 4. Highest power is 4. Write that. For 5, the powers are 2 and 3. Highest 3. So 5 raised to the power 3. Like that. All the primes raised to the highest power. Now for HCF, you must write only the common primes. You must write only the common primes. And when we say common primes, it should be common to all the 3, not any 2. Not any 2. It should be common, meaning common to all. So tell me the primes common to all the 3 numbers x, y, and z.
2.
2. 2 is the only prime which is common to all the composite numbers x, y, and z. And raise this to the least power. What are the powers of 2? We can see 4, 2, and 3. 4, 2, and 3. So of these powers, the least is 2. So the HCF of the given numbers, the HCF of the composite numbers x, y, z is 4. LCM, all primes, greatest power. HCF, common primes, least power. All right. That completes this presentation. Yeah. Prove that root 2 is an irrational number. Hence, show that 3 by root 2 is also irrational. Just a second, children. Yeah, so we are now not going into how to prove that root 2 is irrational, because I think for the number of exams if you had in your school, you must have definitely learned this part. I'll check this later. So for now, I just assume that all of you know how to write that. Okay, what do you call that proof? Tell me that. What is that proof called? All of you have learned real numbers in school, right? Class?
Yes, ma'am.
Yeah. Now, so how do you start? If possible, let root 2 be a rational number. Then it's of the form a by b, where a and b are co-prime. So then it goes like that. That proof, what do you call that proof? Anybody wants to answer that? How does the proof end? So we say that the situation is not possible, and it's not possible because of our incorrect assumption, right?
Yes, ma'am.
Yeah. So yeah, so it's like you assume an incorrect thing. So since we assume an incorrect thing, when we work it, we come to a situation where it's contradictory. We would have assumed that root 2 is rational, but somewhere you will realize that no, it's irrational, meaning it's not rational because it has a common factor other than the when you're working for root 2, you will find that 2 is a common prime. That is the when you assume that a by b, we say it's in the simplest form. Simplest form meaning it is no further divisible. That is the numerator and denominator have nothing in common other than 1. A by b, let root 2 be equal to a by b. If possible, let root 2 is equal to a by b, where a and b are co-prime. That is a and b. The a by b is in the simplest form. Simplest form meaning a and b, the numerator a and the denominator b, have nothing in common other than 1. But when you work that, you will be able to prove that the numerator a and the denominator b have 2 in common. When you work for root 2, the numerator a and the denominator b have 2 in common. So that, but we assume that it's in the simplest, it should be in the simplest form. But then how can they have 2 in common? So then you conclude by saying that the situation is because of our incorrect assumption, so that contradiction, and therefore root 2 is irrational. So this proof is called proof by contradiction. Contradiction. That is, you're assuming the opposite. It's like saying, it's something like this, children. See, you're in the dark, okay, and there are only two, there are only two kinds of animals there, cats and dogs. All right, cats and dogs, like rationals and irrationals, cats and dogs. So supposing, for some reason, the animals are quiet. The pets are quiet. For some reason, they're very quiet. So you just get hold of an animal in the dark and you assume it to be a dog. You assume it to be a dog. Okay, so you don't know. You just assume it to be a dog. But, like later you hear it bark, or you feel its body, and then whatever you realize that it's not it's barking. So it's a contradiction, right? Oh, sorry, 1 minute. What did I say? There was somebody disturbing me here. Sorry. So I was telling cats and dogs, you are in the dark, and for some reason, the animals, they are quiet. You actually get hold of a cat, but you think it is a dog. You think it's a dog. It's a cat. It's actually a cat, but you think it is a dog. Okay, so it's a cat, so it'll mew. The cat mews. And I don't know what else, what other difference I can bring. I'm only telling you this one. So the cat mews. But how can it mew? You thought it's a dog, right? But it's mewing. It should actually bark, but it mews. So your assumption that it's a dog is incorrect. So it's a cat because it's mewing. In the same way, you get hold of this irrational number and you assume it to be rational. But later, for some reason, you understand that it does not have the qualities of being rational. Therefore, it is irrational. Why? Because there are only two things possible. Real numbers exist only in these two forms. Either they are rational or irrational. Like in the dark room, there are only cats and dogs. Okay, in the dark room, there are only cats and dogs. If the animal is not a dog, then it has to be a cat because there are only cats and dogs. Similarly, real numbers are made up of rationals and irrationals. So if it is not rational, it has to be irrational. There is no choice. It has to be irrational. So you get hold of this number, root 2, and you assume it to be rational. But then when you work, you find it has qualities of being, it does not have qualities of being rational. When you work, you find out that it does not have qualities of being rational. Therefore, it is irrational. It's not rational, no, then it has to be irrational, like that. Okay, so that proof you've already learned, and I'm sure you know it. Assuming that I'm going ahead. Now show that 3 by root 2. If root 2 is rational, so you've proved that. Now using this proof, you should show that 3 by root 2 is also irrational. 3 by root 2 is also irrational. Okay, so again, maybe in the next class, I'll ask you if you learned it in a different way. Now you can do this like this. Now, if possible, let 3 by root 2 be rational. If possible, let 3, if possible, that's very important. If possible, let 3 by root 2 be rational. Then it's in the form A by B. Then it is of the form A by B, where A and B are co-prime. Where A and B are co-prime. That is, they do not have any common factor other than 1. What are co-prime numbers? Co-prime numbers. Co-prime numbers need not be prime numbers. They are two numbers whose HCF is 1. Co-prime numbers are two numbers. They need not be prime numbers. Two numbers. If the HCF of A and B is 1, then A and B are co-prime. Any two numbers. If the HCF of any two numbers A and B is 1, then A and B are co-prime numbers. They need not be prime. A and B need not be. They may be prime. They need not be prime. Both of them can be composite. If the HCF of two numbers A and B is 1, then A and B are said to be co-prime numbers because their HCF is 1. So if possible, let 3 by root 2. If possible, let 3 by root 2 be rational. Then it's of the form A by B. But A and B is in this, A by B is in the simplest form. That is, their HCF is 1. So that's what it is. A and B are co-prime, where A and B are co-prime. Of course, the denominator B is not equal to 0. The denominator B is not equal to 0. The HCF of A and B is 1, meaning it's in the simplest form. And B is not 0. Now, upon cross multiplying, you get root 2A is equal to 3B. Now, the idea is to, what are rational and which one is irrational. So you collect all the rationals and irrationals on different sides. So now let's have root 2 on this side, and we'll write this as 3B by A. Root 2 is equal to 3B by A. Now, what can you say? 3 is an integer. It's rational. And A and B, they're also rational. A by B, where A and B are integers. Correct? What is A by B? The simplest form of the rational number. A by B. So A and B are integers. 3 is also an integer. And this one is made up of integers. So it has to be rational. The right-hand side, which is 3B by A, has 3B and A, where all the three are integers. And this combination can only produce a rational number. Integers, whether you add, subtract, multiply, divide, can only give rise to a rational number. You cannot get an irrational number using integers. Sum, difference, product, quotient of integers cannot give rise to an irrational number. So this one is rational, but the other side, there's an equality, right? We have the equal to sign. 3B by A is rational, but this one we have proved is irrational. Root 2, we have proved it's irrational. So this is a contradiction. Now we have an equal, we are saying this is an equality, but it's not possible. And this contradiction is because we have made an incorrect assumption. that 3 by root 2 is rational. This contradiction is because we have made an incorrect assumption that 3 by root 2 is rational. Therefore, 3 by root 2 is irrational. First, we have to prove that root 2 is irrational by using that proof by contradiction. Proof by contradiction. That's the first step. Do this proof. After that, you should take up 3 by root 2. If possible, let it be this. Cross multiply. Have root 2 alone on one side. Transpose A. Now this one is irrational because we have proved it's irrational. Now let's understand this one. 3, B and A are integers. So this one makes a rational number. So this side, the RHS is rational. So this situation is not possible. And that this situation has, we have come up with this situation because we have made an incorrect assumption that this one is rational. So that means this one is not rational. So it is irrational. If it is not rational, it is irrational. Look at this. Prove that root 2 plus root 3 is irrational. Root 2 plus root 3 is irrational. We have 5 minutes, so I have a class after yours. Let me do the simpler ones. Now look at this one, children. Prove that 5 minus 2 root 3 is irrational. So now we know that when you work with rational numbers, a rational number plus a rational number is always rational. A rational number minus a rational number is also rational. The product of two rationals is the rational, and the quotient of two rationals. Okay, the quotient of two rationals is also rational. So that means when you work with rational numbers, the result is always rational. We know this. We have seen it in 9th standard in the chapter number systems. Number systems. When you work with rationals, you'll only get a rational number as a result. You cannot get an irrational number using only rationals. Rationals are represented by the letter Q. Correct? Rational numbers are represented by the letter Q because rational means A by B, right? A by B meaning it's a quotient. So Q from the word quotient. Q from the word quotient. Why quotient? Because rational numbers are of the form A by B. A by B is division. Division means quotient. A by B rational. A by B means quotient. Quotient Q. So rational numbers are represented by the letter Q. So Q plus Q is equal to Q. Q minus Q is equal to Q. Q multiplied by Q is equal to Q. Q by Q is Q. Okay, so with this knowledge, 5 minus 2 root 3. 5 minus 2 root 3. Oh no, this I cannot do using that 1 minute. Let me see if I have another question. Yeah, I think this, yes. Yes, children. Let me start with this one. Yes, children. So based on the, the knowledge which we just recalled regarding the rational numbers, we'll do this. Now, when you take up 1 by root 2, okay. Now, supposing we assume this to be rational. We assume this to be rational. All right. So when you multiply a rational with a rational, what are you supposed to get? A rational number. When you multiply a rational with a, we just recall that rational plus rational is rational. Rational into rational is rational. Now we know that 2. We know that 2 is rational. We all know that 2 is rational. Or we assume this to be rational. If possible, let 1 by 2. See, this is all proved by contradiction. You're trying to say that it is not rational and hence it is irrational. We are trying to say that it is not rational. So it is irrational. Now we'll assume 1 by root 2 to be rational. If we multiply this by a rational number, 2 is rational. When you multiply this by 2, supposing this is a rational number, when you multiply this by a rational number, the result should be rational. Now, what happens when you multiply this by 2? You get root 2. Is root 2 now? See, you have to get results like root 2, root 3, root 5, because only these we have proved as theorems. Okay, so these are like theorems for us. We know this. We have proved that root 2 is irrational. Root 3 is irrational. Root 5 is irrational. These are like theorems for us. So we can use the result of these theorems. So we have proved that root 2 is irrational, root 3 is irrational, root 5 is irrational. So it's like we are getting this result using the theorem. Now again, 1 by root 2, if possible, let it be rational. So if this is rational, when you multiply this by another rational, 2 is rational. We know 2 is rational. When you multiply these two, the result should be rational. Now we'll multiply. What are we getting? We are getting root 2. But root 2 we know is irrational by the theorem. Because root 2 we have proved it's irrational. Root 3 irrational. All this we have proved. Root 5 irrational. Root 7 irrational. This we know. So the product of two rationals must be rational. But we are getting an irrational. So our assumption is incorrect and hence 1 by root 2 is not rational and it's irrational. Am I clear, children?
Yes, ma'am.
The product of two rationals is rational. 1 by root 2, if possible, let it be rational. We'll multiply this by 2, which we know is rational. When we multiply, the product should be rational. But we are getting root 2. By the theorem, we know that root 2 is irrational. How can we get rational into rational? Must be rational. We are getting irrational. That is because of our incorrect assumption that this one is rational. So it has to be irrational. So this is a proof by contradiction. It is not rational, therefore it is irrational. Similarly, using the same thing, you can prove 5 minus 2 root 3. All right. Just a minute, children. Yeah. Yes, children. So 5 minus 2 root 3. So now we'll have to do all that so that we have only root 3 remaining. We'll have to do all that so that only root 3 is remaining because we know that by the theorem root 3 is irrational. We know that root 3 is irrational. So we'll have to do some addition, subtraction or multiplication or division so that we are left only with root 3. Now let's see what can be done. So we start by saying that if possible, let this be rational. If possible, let this be rational. So now let us say subtract 5. We know that this is rational. 5 is rational. Okay, so we are assuming this to be rational minus 5, which is rational. So the result, we are getting some result. What is the result now? This gets cancelled. So you are getting minus 2 root 3. Now proceed because you have to have only root 3 remaining. So now proceed minus 2 root 3. What should you do so that you have only root 3 remaining? You'll have to multiply by minus 1 by 2. You'll have to multiply by minus 1 by 2. Minus 1 by 2, you know, is rational. Minus 1 by 2, you know, is rational. This product, this is a product, sorry. And this one is also rational because that's what we have assumed, right? This is rational minus a rational. So we feel this is rational. We are continuing that rational into a rational. Into a rational should be rational. But what happens? 2 gets cancelled. Minus into minus plus, and we are getting root 3. You should get a rational. But no, this is irrational because we know that by the theorem that root 3 is irrational. But we thought this one is a rational. That's what we supposed it. And product of a rational should give you a rational. But you're getting root 3, which you know is irrational. So this is a contradiction. That is because we assumed this incorrectly, that it is rational. Therefore, it is irrational. So what you'll have to do? You must do all that so that you're left only with root 3. So what I first did is I subtracted 5, which is rational. And you are left with this. Now you have to get rid of this minus 2. For that, you'll have to multiply by minus 1 by 2. It's reciprocal. It's reciprocal. Minus 2, the reciprocal of minus 2 is minus 1 by 2 multiplied by its reciprocal. So now you're left with root 3. Now root 3 is irrational by the theorem. But it should be rational because the product of two rationals should give you a rational, but it's irrational. That means our assumption is incorrect. Therefore, 5 minus 2 root 3 is irrational. So what will you do for 3 root 7? 3 root 7? You must do all that so that you are left with only root 7. So let's multiply by 1 by 3. You should do something so that you are left only with root 7. And by the theorem, you know that root 7 is irrational. So you start by saying, if possible, let this be rational. So if this is rational and you multiply it by a rational, like 1 by 3. If this is a rational and you multiply it by a rational like 1 by 3, then the product should be rational. But this is irrational by the theorem. So this is a contradiction. You should get a rational, but you're getting an irrational. How do you know it's irrational? By the theorem. It's irrational. And this is because the situation is because of our incorrect assumption that this is rational. Therefore, this has to be irrational. Similarly, for 3 plus 5 root 2, subtract 3 first. So you get 5 root 2. Then 5 root 2, multiply this by 1 by 5. Multiply this by 1 by 5. So 5 and 5 cancels. So you get only root 2. And what did we do for 1 by root 2? Multiply by 2 because 2 is rational. Multiply by 2. So you get root 2, which you know is irrational. Is this part understood, children?
Yes, ma'am.
All right. Yeah, children. So all these notes I'll share with you as soon as possible. Just give me some time. I need to type and then make the presentation. So I'll just need some time. So in the meantime, children, I'm very concerned about students who missed the classes. So again, I'll call out. Meera, have you attended all the classes this week?
Ma'am?
Meera, have you attended all the classes this week?
Only one class. Yes, ma'am, I attended. That on the time I kept that meeting for 30 minutes for discussing about the holidays.
Okay. Oh, only that you did not attend. No, fine.
Yes,
Ananya, I already told you what you should do. Kanishka, you missed one class, right?
Only in that leave, I think, no, ma'am.
No, did you take up all the classes conducted this week?
Yes, ma'am.
Okay. Nandini?
Yes, ma'am. I also took up all the classes this week.
Very good. Priyanka?
Yes, ma'am. I attended all the classes.
Yeah, Priyasha, I only remember that you missed the first 1 hour of class where you had texted me that you were not keeping good health, right? Priyasha?
Last class, yeah.
Last
class was 1 hour.
Yeah. So other than that, you have taken up all the sessions, no? Completely?
Yes, ma'am.
Yeah, so Priyasha, please watch that 1 hour recording and let me know that you've finished it, okay? Please text me on WhatsApp once you're done with that. Yeah. Ram?
Day before yesterday's section, I was absent, ma'am.
Okay, Ram, please watch that recording and, let me know that you're finished. All right?
Yes, ma'am.
Yeah, Shri?
Yes, ma'am. I have attended every class.
All the classes. Very good. Sneha and Harini?
Ma'am, we have not attended last 2 classes.
Yeah, darling, please, both of you, both the girls, please watch the recordings, meaning the classes you missed, the recordings of the classes you missed, and let me know on WhatsApp, okay?
Yes, ma'am.
You can write later. You should write, but first watch the recordings. All right? It's all updated. Yeah. And Lakshmi?
Yes, ma'am. I have attended all the classes.
Very good, very good. All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you,
Thank you,
children.
ma'am.
Thank you.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Very nice. Thank you.
Thank you, ma'am.
Thank you.